Well, ladies and gentlemen, it's time to introduce our guest speaker, Mr. Prageeth Kapuruge, on stage. Let's welcome him with a round of applause.
Thanks for that introduction. And thanks, Bhushan, for giving me the opportunity to discuss such a timely topic. So when you look at today's threat landscape, attackers are getting smarter, faster, and more automated, all thanks to AI. And I see a lot of organizations are struggling to keep up with this phase because they are stick to their traditional security controls and the manual workflows. So today, my focus is to show you how we can better use AI to really defend against those new threats in practice. So before going into the details, let me ask you, what's your biggest challenge in cybersecurity operations today? Anyone? How about alert fatigue? Too many alerts? Too many false positives to deal with? Too many tools that you have to use to triage the incident, to remediate the incident? Lack of context to really figure out whether this is business related? Talent shortage, I'm sure. This is not just in the cybersecurity, but every field, we have this challenge. Too many manual workflows to deal with. Fast and smart attacks with AI. So if you don't see this as a challenge today, you will soon realize this as a challenge when the attackers start adapting AI more and more. High cost of operating 24/7. So I'm pretty sure most of you has either one of more of these challenges when it comes to cybersecurity operations. So what's the solution? How can we address these pain points? What if I tell you there's one technology that can help you out with all these challenges? Yes, you heard that right. That is AI agents. They are smarter, they are faster, and they can help you out with those pain points in cybersecurity operations. Before going into the details, we'll see how AI agents evolved to this level. So a couple of years back, when the Gen AI and the large language models are introduced, artificial intelligence became very popular. But there were three main challenges of Gen AI. The first one is, it can tell you what to do, but it cannot really do that for you. For example, if you ask it, how remediate this malware infection, it will tell you to follow these steps, but it cannot really take those actions. And the other challenge is, it doesn't have access to the real-time data. After the training cutoff date, it doesn't have the recent knowledge. For example, if you ask it, what are the current active alerts on my EDR, it doesn't know because it doesn't have access to that. Plus, it is not trained on that data. The third limitation is, it doesn't have access to your organization-specific data. Most of the public LLMs are trained on publicly available information. So it doesn't know what your internal architecture is, what your internal services are, which will be needed to really analyze a cybersecurity incident or a site reliability engineering incident. So to address the first two challenges, AI agents are introduced. To address the third challenge, RAG, Retrieval Augmented Generation, is introduced, where you can upload your company data, the architectures, all that into a vector database, and the RAG will real-time fetch the relevant content from the vector database and enrich the user request. So the LLM understands the request relevant to your organization. It knows the relevant stuff to your organization, so it really understands what the request means from your organization's point of view. There are two key components of AI agents. The main component is a LLM that acts like the brain. It is the component that processes the data. It is what is going to do the reasoning and try to do all the analysis. It's a brain behind the AI agents. And then there's a concept called tools, which can take actions based on the guidance and the instructions given by the brain or the LLM. So those are the two main components of the AI agents. For example, you can connect your EDR API to the agent as a tool. So if the agent wants to remediate an incident, if it wants to quarantine a host, it can talk to the EDR API and execute the necessary API calls to do the quarantine action. And you can connect your SIEM API as a tool to the agent, so the agent can fetch the relevant logs related to the incident and then forward it to the brain to analyze and to really decide whether this is a true positive or a false positive. Likewise, you can connect multiple number of tools so that agent can really execute those actions that is given from the LLM. So why do we say the AI agents are really a game changer? Why are they so powerful and how are they really special compared to our traditional technologies? The main reason behind this is it understands and reasons like a human. It understands the request and do the reasoning just like a human would do. Your traditional technologies will do the pattern matching, signature matching, all are static controls. It doesn't understand, it just looks for the keywords. But the AI agents, with the help of the LLM, will really understand the request. If you feed a log message, let's say it says there's successful RDP login to your server. Then it knows what is RDP is, how that service works, how that protocol works, what are the best practices around that protocol, what successful means, what login means. It really understands that log message and process it and then decide what to do next. This human-like understanding and the reasoning is what is going to make the difference. All this is happening at machine speed. It can analyze millions of log messages at the machine speed. And this automation is not just a if and then static check that's happening like in the traditional concepts. It understands the input, it processes it, and then decides based on the available tools what to do next, just like a human, how a human being would do. And there is continuous feedback loop that will happen. Every time it executes a tool, the agent will send that output to the LLM. LLM will analyze and figure out whether it is satisfy the original request. If it doesn't, it will again decide what tools to execute, get the output, again send to the LLM. This loop will go on and on until a satisfactory output is received. That's how the human also operate, right? They'll take a step-by-step approach. They'll do execute, look at one dashboard, look at the details, analyze the logs. Based on that, it will figure out the process will be followed by the AI agents. With that, let me introduce Sentinel AI. This is not the Sentinel product that is out there. This is our in-house built team of AI agents to help our teams with cybersecurity operations as well as site reliability engineering. So these set of agents are doing the first level of triaging and the initial remediation for whatever the actions that we have allowed it to do. This is the architecture of the security components of the Sentinel. So this is not the exact setup that we are running. This is sort of a scaled down version. I have put what is really necessary for you to understand the concept. So there are three core agents. The one that is highlighted in blue, this is a triaging agent. Then we have a remediation and notification agent. Then we have the change tracking agent. The triaging agent has the tools connected, all the tools that a human would use to do the triaging, all that is connected to the triaging agent. It has the Bloodhound connected, SIEM, EDR, vulnerability assessment, threat intel feed. I have just shown few of the tools, but there are a lot more tools connected that it really needs to do the triaging accurately. And it has a vector DB that is one of the most important components. That is what is going to give the organizational context to the LLM. We have uploaded our internal architectures, documents, KBs, runbooks, all that to the vector DB. That RAG is going to dynamically fetch the relevant context from those documents and feed into the LLM So LLM has the understanding of our local context, how we have architectured our microservices, what are the services that we are running, what are the servers, what are the roles of those servers, all the relevant information will be fed into the LLM. So it has that local context when it does the analysis and the reasoning. Change tracking and the remediation agent, it has all the tools that it needs to do the remediation and the notification, the firewall APIs, AD integrations, the EDR APIs, the teams to send the notification, calling API. If it needs to get a human involved for an emergency situation, it can call the calling API. Then we have the change tracking agent. It continuously monitor our production state, our production deployment, to identify if there are any changes. If there are changes, it is going to analyze the change and really figure out whether it is malicious change or if there's a production impact due to that change, and then take the next set of actions. So this is just a sample scenario that I have put on for you to understand how the flow works, right? So when you look at, So when you look at the triaging agent, there are two ways that it can get triggered. One is through the Teams channel. That is when our team wants to talk to the agent, right? When the team wants to ask questions from the agent, when Teams wants to get the agent to do certain actions, they can talk to the agent through the Teams channel. The other option is SIEM. We have got it to send the alerts to the AI agent through the webhook so that AI agent can do the necessary triaging and take the necessary actions based on the alert, right? So this is just a sample alert that I have taken. This is not actual alert. So let's say it's suspicious process task.exe with the file hash detected on a workstation, right? So from the SIEM, that alert will be sent to the triaging agent. Triaging agent will look at the message, and with the details of the tools available to it, and with the context fetched from the RAG, it will send all that to the LLM, because that is where the brain is, that is where the analysis is going to happen. The LLM is going to analyze all the data and then figure out what's the next step to do, and all those instructions will be passed back to the agent. Why? Because the agent is the hands and the legs that execute those instructions. So, for example, the instruction might be to fetch the relevant from the SIEM for this host. That can be one of the instructions. And there can be another instructions to do a reputation lookup of this file hash on the threat intel feed, right? So let's say, assume those are true instructions. Then the agent is going to look at those instructions, the tools that it needs to run those instructions, run those tools, get the output, and again send it to the LLM, because you need brain to process that. Then the LLM will process that, compare it with the initial request, and really see whether there's a satisfactory triaging. If not, it will again call another set of tools. For example, if it sees this particular process has connected to a set of another internal systems based on the SIEM log, it might decide to fetch the logs relevant to those systems as well. So then there'll be another tool call. Agent will call those the tools again with the right filtering and get the logs and send to the LLM. Then LLM with the previous details and the new details, it will analyze everything again and again decide whether the triaging is satisfactory, what to do next. This process will continue until there's a satisfactory triaging up until a final report or the necessary remediations happen. Oh, this is just one sample triaging that it has done. What you have on the left side is a full triaging report, and I have zoomed certain important points for you to really understand how it has done the processing, right? So the alert is unusual role assumption on AWS. On the AWS, there's this concept called role assumption. You can create different roles with privileges, and then you can allow your services to assume those roles to use those privileges, right? So we have our CI/CD pipelines, and our continuous deployment is taken care by Argo CD. That's a continuous deployment tool that we use. And that tool has a specific role that we have created for it to access the necessary services on AWS. So this complaint is about that role causing some abnormal behavior, right? So then this alert was sent to the triaging agent. So look at what it has done. There are multiple successful assumption of the roles originating from your trusted AWS public IPs. How does it know that? It has fetched the relevant logs from the SIEM, and it has identified the IP addresses. Then it has again looked at the vector database and fetched the data to really figure out what those IP addresses are, and it has decided these are our own IP addresses. So it knows this is happening inside our tenant. It's not some external parties trying to assume one of our internal roles, right? So next, it has looked at what are the actions that the call has performed, right? Those actions, it has tried to decrypt one of the secrets that is part of the workflow, So it has identified that because it knows how Argo CD works, it knows that this is part of the normal behavior. How does it know that? Because these LLMs are trained on millions of data like that. So it knows how the normal behavior is. With that context, it says this is part of the normal workflow. And it has again go through the logs to really figure out if there are any other unauthorized activities happening. And it hasn't found anything like that. So the final verdict is this is false positives. All this is happening within seconds. All this analysis is happening within seconds, and the conclusion is given. And since it is false positive, there is no remediation required. So this is another example where I was talking to the AI agent. I wanted it to analyze one of the hosts to see whether there are any abnormal activities. And it has gone through the logs. It has fetched the logs. It has run the necessary tools, got the logs, and analyzed it to see whether there are really abnormal activities. And what it has found is one of the remote access tools running on the machine. And the conclusion is this might not, and it has checked the reputation of that hash and validated that that is a published, well-known hash by that remote access tool organization. So it has confirmed that there is no any compromise as such. But what it is saying is this is not a security incident, but from the code of conduct violation point of view, this can be considered as a violation. So these are certain analyses done by our production tracking agent. So the first screenshot, it has detected our release changes in one of the production microservices. It has detected from 2.21.9 to updated release happening. So what it has done is it has gone onto the GitHub, and it knows what the previous release was. It knows what the new release is. It has fetched the code diff from the GitHub and then analyzed that code diff to really figure out what's the impact of that change, whether there's a security impact or a production impact. And one of the findings is, so the second screenshot, I have masked some of the sensitive information. So in the second screenshots, it has identified a risk, a possible SQL injection risk that we anyway had identified and had added to the tech debt. So how did it do that? Because it knows programming, it knows the best practices, it knows how the SQL works. With all that knowledge, it analyzed that code diff to figure out what it really does. So the third screenshot, another deployment change. There the change is one of the microservices deployment, we have changed the replica count. We have increased the replica count, right? So that means more replicas will be running. So it hasn't detected any security impact, but it has highlighted there can be a cost impact because now you run more replicas than what you used to do. How does it do that? Because it knows Kubernetes, it knows how the deployment works, it knows how the scaling works, so it can analyze and really figure out the impact of the change. Not the string matching, not the pattern matching, no regex matching. So this is another test that we have done. So one of the test repos, we injected a reverse shell. We really wanted to see how whether the agent can detect it and really figure out whether it's a reverse shell or not. So this change was detected by the Sentinel. It analyzed that code diff, this reverse shell code, and then it accurately identified that this is a reverse shell committed to the code base. It is recommending to revert to a known good release. So we haven't given the permissions to do any release changes for the agent. Otherwise, it could have gone ahead and revert the release also. So this is the SRE piece of it, site reliability engineering piece of it. There are two main agents. Like I said, this is not the exact replica of what we are running. So this is just to help you understand the concept. So there are two agents, the triaging agent and the remediation and notification agent. Triaging agent has all the tools that a human need to do the triaging of a site reliability engineering incident or a detection, right? All the tools like our database access, the read-only access, the access to our loggers, the AWS CloudWatch, the vector DB with our context, all that is given. And then you have the remediation agent, which are tools connected that is needed to do the right remediation. So these are a couple of triaging that it has done. The first one is related to CDC latency. With the Neuralink alert, it triggered the triaging agent. It went to the database, look at what's happening, and it has identified the CDC latency is due to a cleanup job that was running on the database. The second screenshot, a high CPU usage alert on one of our servers, right? So the Neuralink sent that alerts to our triaging agent. Then triaging agent look at the alert, identified the server, log into the server, log into the database of the server because there was a database running on the server, and then look at the queries running, and it has identified what exact stored procedures are causing that high CPU. The third one is a block process alert that was received. There also the agent has gone onto the database and identified what are the processes or the queries that is causing the block. The last one is high IOPS alert, right? There also it has gone on and identified there's a routine maintenance jobs that is running, causing the high IOPS usage. So when you design your AI agents right, you don't have to hop between multiple interfaces. You can talk to the agent and get the work done. So this is me talking to the agent. The first one is I'm just trying to get some statistics or the current status of one of our microservices. The second one is I wanted to analyze one hash to really see whether it's malicious or not. This is what this analysis is. So I used to go through these dashboards in the morning just to understand the health. Now I don't do it anymore. I talk to the agent and get the update. So this is what we are delivering to the business. From the SRE front, we have already delivered this, and we are getting to this on the cyber front as well. 95% noise reduction with the trend and context analysis, 90% cost saving, no missed alerts because agent is awake all the time, and faster resolution time. So that's what I had to cover. Any questions? Anyone who is using AI agents like this in production now? Yeah. So it's really changing the industry. It's really changing things. So it's high time you start adapting, right? Otherwise, you will feel that you start very late because a lot of organizations, they're looking at how they can adapt because the potential is very high. I have just covered few of the scenarios, but this is not everything that it can do. It can even help you out with your business processes, not just the SRE or the cybersecurity, right? There's huge potential. So start working on that, start adapting. If there's no questions, thank you very much.